We're going to take a look here at lesson 8.1. We're looking at lesson 8.1. Some things you might want to open up in particular is if you go to your classroom, is for the bell ringer, we will use the formula chart. But then after the bell ringer for lesson 8.1, I'm going to get away from the formula chart and I'm going to kind of walk you through, and we will use Desmos to help us out mathematically to solve these problems. And so I would encourage you to open up the Desmos pre-programmed graphs as I have opened up in that tab. But for the bell ringer, I will use the formula chart. So I'm going to open this up and we'll take a look now at number 1 here on the bell ringer. Number 1 says write an equation in standard form for the hyperbola with foci listed at those 2 spots and vertices listed at those 2 points. So let's take a look on number 1 here. If I were to graph this, I realize I'm kind of going out of order here. Normally, I'd write down the common parts of the hyperbola formula between the vertical and horizontal equations for a hyperbola here. The common portions is that you always have a parenthesis squared over a squared minus another parenthesis squared over b squared equals 1. So I will go ahead and write that down now. So we have some parentheses squared, which we'll find out whether it's x minus h or y minus k over a squared minus another parentheses squared over b squared equals 1. And the other important detail that we talked about in chapter 7, and that's really what this is reviewing, is that for hyperbola and ellipse, the word of foci and vertices are going to be very important, these two. You know your vocabulary. Foci, is that 2a, 2b, or 2c? Very good. I hear in my classroom that it's 2c. And what about vertices? Was that 2a or 2b? It was 2a. That's right. 2a. So when I plot these points, we can determine a lot of different pieces of information. The foci, we have one that's down 4 units. So 0, -4 would be plotted right there. And 0, +4 would be up 4 units. So I will plot these 2 foci. Here's one foci. Here's the other foci. Or I should say one focus and the other focus together, they make a foci located at 0, 4, and this one at 0, -4. Okay, the first question comes up. If the distance between them is 2c, then what is that total distance? This is 4 units down, this one's 4 units up. How far apart are they? 8 units. And so just to carry on, some information that we frequently need is not only do we need to isolate the c value, which we could do by dividing by 2. So we could isolate c and discover that c is 8 divided by 2, which equals 4. But what's frequently needed is the value c squared. So 4 times 4 would be 16. I'm going to go ahead and write that. We can get a lot of different information off of this. You could find the center of this hyperbola is going to be located at 0, 0. Now you might be thinking, how did you know that? Well, because c is 4, which means if you go from one foci 4 units towards the other foci, you would find the center. So this is the center at the origin 0, 0. It tells us that. It tells us also that this is going to be a vertical hyperbola because every shape, no matter what, opens around the foci. And so I would have hyperbolas, or it kind of looks like 2 parabolas that open around each foci. So it's vertical, meaning the foci will always tell you which direction your a's are going. This is going to be a y here and the x here. Why do I know that? Because it's a vertical hyperbola. It's opening up and down. So the y is going to be in the fraction that is positive, meaning a positive fraction there. The x will be found or located in the fraction that's negative, right here. All that was determined based upon the foci being up and down. But even if you didn't know that, you could continue on to the vertices. Oh, by the way, 0, 0, no transformations. So I'll put that in there. The vertices, if we placed, vertices mean 2a. And so when I plot these two, down 2, there's a vertice. you can see that it is in fact true that this will be vertical because 2a is going up and down. So the y, since it's moving up and down the y-axis, the a squared is going to be underneath the y squared as my other vertice at 0, 2. Forgot the letter v. There, put that in there. There you go. And so we don't know what the hyperbola will exactly look like, but just to kind of give you a rough estimate, it would be a hyperbola looking like this, something similar. The vertice is always like the center of a parabola, if you will. So it'll look something similar to this. All right, so how do I solve the rest of the problem? Well, let's see, 2a, that's the value from vertice to vertice, which is 4 units. So coming back here, 2a would equal 4. And if I isolated the a value, what does 1a equal? If 2a equals 4, what does 1a equal? 2. And what's frequently needed is a squared. What is a squared going to equal? 4. So I could put a 4 in here for a squared. So the last thing to complete this formula, well, I shouldn't say last, I should simplify this. Y minus 0 is y, so I can just read y minus 0 quantity squared is just y squared. Same over here, x minus 0 is x, so x minus 0 quantity squared is just x squared. Let's do that, that makes it look better. And now to find the b squared, there's no other information here, I can't see a b here, but on the formula chart, we can be reminded that for a hyperbola, there's always a relationship for both ellipse and hyperbolas between the letters a, b, and c. And for a hyperbola, the relationship is that c squared equals a squared plus b squared. So I could write that in over here and solve for b squared. A squared is going to equal, no, I wrote that wrong, sorry. C squared is going to equal a squared plus b squared. Our problem, we already solved for c squared. We got 16. We solved for a squared. We had that was 4. What we did not have is b squared. You might be a mental genius, mental math genius. You might know that that number is going to be 12. But if you did not know, how would I algebraically discover? I would subtract 4 to isolate b squared. And 16 minus 4 is 12. So 12 is b squared. You don't actually have to solve in this problem for b. So I can just say it's 12. All right, since I talked about the calculators earlier, I will show you that let's just say you had multiple choice if you wanted to use guess and check technique where you graph the different hyperbolas. Could we get an answer? The answer is going to be yes. On my list, it's calculator number 21 for hyperbolas here. I have 2 different links. One's for the horizontal, one's for the vertical. How would you know? Well, we discovered that y squared needs to be positive. The x squared needs to be negative, so I'm choosing the second link. So I'll choose the second link here. We had a shift, or no, we did not have any shift. We were at the origin, so the h and k needs to be 0, 0. That's for the origin, or the center of the graph rather, at the origin. My a squared was 4, so a is the square root of 4. B squared was 12, so B would be the square root of 12. I typed that in. If you check your values, you can see we have a focus at 0, 4, focus at 0, negative 4. That's exactly what our problem gave us right there. They also gave us vertices at negative 2 and positive, excuse me, 0, negative 2, and 0, positive 2. If I click them, it says vertex, vertex. Those are my vertices. So we did it correctly. That's number 1. All right, let's take a look at number 2. Number 2 says, which of the following represents x equals negative 4 plus 2t and y equals 5 minus t in rectangular form? But there's no multiple choice. It says, which of the following? You would think there would be multiple choice. Well, on Power School Learning, you probably have it, but I'm going to work it through just algebraically. If you remember, this was a 3-step process. When you're given 2 equations, this is parametric, and having to convert it to rectangular form. Does anybody remember what step 1 was?
Isolate the t.
You solve for your shared variable. So yes, we want to isolate the t. Solve for shared variable. That was our first step. Okay, so what variable is shared? We've already been told. Jasmine said it was t. So I'm going to take my x equation. So I usually start with the x, solve that, and substitute it into the y equation. So x equals -4 plus 2t. All right, we're going to solve for this t here. How do you get t isolated? How would I get rid of a -4 or -4? You add 4. So I have x plus 4 equals 2t. And now finally, to isolate that t, the t is being multiplied by 2. What's the opposite of multiplication? Division. We could divide by 2. Now I want to simplify this fraction. Division works just like multiplication in the sense that you can distribute it. And so I'm going to say that t is going to equal, I'll distribute the division by 2, x over 2 plus 4 over 2, which is just simply 2. So that's step 1. I solve for the shared variable. Step 2 is we substitute this. So I'm going to substitute what we just got into the second equation. Y equals 5 minus, and instead of t, I will substitute the t with what we just discovered, t equals x divided by 2 plus 2. Step 3, we simplify this. So I'll distribute that negative through. So we're subtracting the whole parentheses, the whole quantity in there. So I need to subtract each portion. So it'll be minus x over 2. It's kind of like distributing a -1 through. That's the idea of what's happening here. And so we'd have minus x over 2 and a -2 value. And so our solution here appears to me, when I combine my like terms, I'm going to write the x quantity first, will be minus x over 2. I wrote that term first. And then what is 5 minus 2? 3, positive 3. This should be my solution there. And I have a calculator for this to check our answer. If we had multiple choice, if you wanted to use guess and check. This is calculator number 22, parametric equations. That's all, 3 equations with the terms of t. The first equation we were given was that x equals -4 plus 2t. The y equation was that we had 5 minus t. They did not give us the parameters, so I don't know what values of t we should have. So mine just starting off by default is -3 to 2, which graphs this little line here, this portion of the line. If we checked our answer, y equals negative x over 2 plus 3. Notice, do these overlap? We got the correct answer. Again, if you're wondering, why is this one so short? It has to do with this parameter. If I put bigger numbers down here, you would get a longer graph. So that's how that works, for the record. All right, so there was your bell ringer number 1 and 2.